Hey guys, chapter 6, rational expressions, more review. This is from 6.4 and the concept we'll be discussing is dividing polynomials by polynomials using long division. So I'd like to give an example of this by doing regular long division. If I had 1056 and I wanted to divide this by 42, say a 2-digit, then I would say, okay, 42 cannot go into 1 at all, can't go into 0 at all, but it can go into 105 twice. The relationship between the number here and the number here is multiplication. 2 times 42 is going to give me 84. Again, I put the 2 over the 5 because that is the column or the place value which I'm putting the 42 into. I'm putting it into the 105, so that's where it goes. Again, this is 0 here, although it is worth nothing, is still holding that place. Now after we multiply these two together, then we will subtract and we get 21. I'm going to bring down this 6 and say how many times does 42 go into 216? At this point we're not really sure, so we can check. Maybe best guess is 5 times. That's going to be 10, carry the 1, so that's going to be 210. So it is 5 times, and again this 5 is being multiplied by both of these digits, and we get 210 when we do that, and we subtract every place value. So 6 minus 0 is the 6, and this is right here. After I've put something into the last digit or the ones place, this becomes the remainder. And we would write this as a fraction, 6 over 42. Then of course we would reduce this fraction to 1/7. So the answer here would be 25 and 1/7. Now we're going to use the same process to do a polynomial to divide. Let's start with 2x squared minus x minus 10 and divide that by x plus 2. So just like this is a 3-term polynomial and a 2-term polynomial, you know, we've got several digits here and a 2-digit. We don't always know what we're multiplying by, so what we're only going to worry about, but as long as it's 2 digits here and not a single digit or a single term, we're dividing by a polynomial, so we want to do long division. So we'll divide it this way and say, oh, we're dividing by x plus 2. But when we're talking about polynomials, we just take the x and we say, well, what would this leading coefficient, what would I need to multiply this leading coefficient by to make it 2x squared? And that would be a 2x. I'm going to put that 2x here in my x column because it's not squared, it's x to the 1. So I'm going to take 2x and multiply it by x plus 2. The same thing we did here. The 2 times 42 is 84. So I'm going to take the 2x and distribute. That's going to give me a 2x squared plus a 4x. But just like we were subtracting right here, we're also going to subtract here. So if I subtract 2x squared plus a 4x, then this subtraction sign also will distribute into there. So what will happen is it'll change both of these signs. So this is going to be a minus and this is going to be a minus. These terms should sum to 0. If they don't, you did something wrong. And a negative x minus a 4x is a minus 5x. And this is what's left. I'm going to bring down my constant column. And I'm going to say, well, what would I have to, I'm going to start the process over. What would I have to multiply x by to make it a negative 5x? The answer to that would be a negative 5. So if I take negative 5 and I multiply it by x, I get a negative 5x. If I take negative 5 and multiply it by 2, I get a negative 10. But remember, I'm subtracting, so both of these signs are going to change. Then when I do this subtraction or combine these like terms, I get a remainder of 0.